Typical oxygen sensor, 4-wire, heater, ground, and signal. We want the black wire for our oxygen sensor. The AFRs, I think, are usually like black, white, and blue. The two blacks are smaller gauge wire. The white and the blue are a little bit thicker. So the white is your reference wire, and the blue is your signal out. Now, everyone familiar with how a typical oxygen sensor works? They've been around since '81. You're supposed to be the best of the best, so I'm going to assume that you do. The AFR is relatively new. I've seen on paper anyways, they've been around since about '98 on a few select cars in the early 2000s. They started becoming more prominent. Now, whereas, oh, and by the way, if you have a 1 or a 2X optimizer, you can tune the O2 circuit with that screw. You have 2 or 3 little holes here. The middle one's an LED. The mounting flange on the bottom, wires coming out, you want the left. So I wrote that but didn't cover it very well.
The AFR is the sensor that goes in the air intake pipe?
Nope, AFR is an oxygen sensor. It's a newer style oxygen sensor.
That's a new style?
It's the newer style. This is the oxygen sensor that's found in the newer cars. So the way this is written, no, it's 4. It's 4-wire. 2 of them are for a heater. And then you have your reference and your signal. And so the way this is written in the textbooks is so this would be your white, and this would be your blue. This is the electronics insignia for a resistor. This is the electronics for a battery. So a typical oxygen sensor will just have a little battery signal in there, and this one has a resistor in there also. Now, let's take a look at a typical AFR, where if we were to take and do a voltage off the white wire, we might see, say, 3 volts. And then off of here, we're going to have a 3 to 4.5 volt range. Essentially, it works the same as what we're all familiar with. In other words, as the mixture goes richer, the voltage goes higher. As it leans out, the voltage goes lower. The voltage will never go lower than what our reference wire is. This 2003 Toyota Camry we did. This is the way that works. There was a 2004 Dakota. It referenced 2.5 volts. So its range was 2.5 to 3.5. So in other words, we have some vehicles where this range here is 1 volt, and then there's vehicles where it's 1.5 volts. Dennis's Honda works off of a 1 volt spread. So this might be your first introduction to the new AFRs. You may already know all this stuff. Yes, sir?
Mike, 2004 Dakota took the feed wire from the computer to power, fed it between 2.5 and 3.5 volts. The signal wire back to the computer still ranged, cycled up to a volt. The half a volt was still its functioning point, and it cycled above and below, just like any other O2 sensor did. It was the feed wire that came from the computer that fed it the power that was what was the 2.5 to 3.5 volts.
Okay, what he's saying is that on this 2004 Dakota, both white and blue wires were varying. Quite frankly, I'm still researching these sons of guns, so if any of you do know intimately how these AFRs work, please see me during the break. Any insight you can help me out with. But this is what I was able to pick up from what studying I've done, so apparently I'm wrong. All right, well, with that said, let's build an install of an optimizer. All right, one of the wires we're going to have is ground. And then we're going to have our key on battery voltage wire. Key on and crank. Very important that it has power when you're in the crank mode. Now the factory ECU will have several wires going to battery. There's going to be at least one wire feeding the ECU that does not go through any switches, does not go through any relays. If anything, it may go through a fuse, and that's it. That's your keep alive memory wire for the ECU. So we found that with a lot of vehicles, you disconnect the battery, hook it back up, and now all of a sudden the mileage goes up and then it starts tapering off, tapering off. You disconnect the battery, it goes up, then tapers off, tapers off. So the optimizer has two wires for the keep alive memory, listed as black and gray on here. So what we do is we go in and we actually cut that keep alive memory wire, and then white, gray, not polarity sensitive. You can hook them up either way, even though the optimizer said it is, but it's not. And then this will actually be rigged up through the switch on the side. So what happens, you turn the key to the off position, there's a relay in the optimizer that will shut off the keep alive memory to the ECU. With the keep alive memory turned off, all your short-term adaptive memory gets reset. So now when you fire the thing back up, it's just like you disconnected the battery and reconnected it, except you don't have to reset the clock and the security alarms and all that other nonsense. The switch allows you to have already hooked this up and then bypass it after the fact. Going on the assumption that the majority of the installs will not have that ungodly relearn procedure, then we labeled this normal and IM test mode. So normal means that this will be disconnected every time the key is turned off. IM test, this switch will actually reconnect this at all times so that when you turn the key off, you still have keep alive memory going to the ECU. When vehicles go in for emissions testing, DRB, OBD2, I'm sorry, I'm a Chrysler guy. The 96 and newer, one of the tests that they do for the inspection is they go in and they check for codes. Part of the programming that goes into the factory ECU is if you reset the codes and then quick go and try to get a test done, it'll fail. Even if there's no codes set, it'll still fail because it has to go through a series of warm-up cycle cool down so that the computer can do some checks and then give it a pass or fail. So if you disconnect the keep alive memory, every time you turn the key off, you will not have that stored data required by law to pass an emissions test. So therefore, you turn this to IM test a couple of days before you go in for your emissions test. You pass the test. After you got your certificate, you turn it back to normal mode. Does everybody understand that? Are there any questions on that? I see you looking like, what the heck's he talking about?
And where there is.
Right. Is there a question back here?
Yeah, what colors are those wires that are connected again?
Okay, the wires coming out of the optimizer will be gray and white. The box happens to have the color codes right on it. So you don't have to write all that down. When you do an install, you can just, see here, white, keep alive, ECU, keep alive memory. Gray, ECU, keep alive memory. Oh, okay. So it's written right on here. It is not play. It says here, keep alive memory in, keep alive memory out, but they are not polarity sensitive. The 4X optimizer, these two wires will be the same color. There's going to be a lot of circuits on the 4X where we're going to use the exact same color where two wires are involved because there are 12 standard automotive grade wire colors. There's 12. And when we need that 13th wire, we have to special order that wire. And it'll add some money to the cost of the unit. So to try to keep the special order wires to a minimum, those two wires will be the same color. And I'll point out as we go along which wires will also have the same color. Any question on keep alive memory? Yes, sir.
So that is so, when they are the same colors, it doesn't matter which one gets.
Yes, when they're the same color on the 4X, there is no polarity sensitivity. If there is polarity sensitivity, there will be some designation between the two wires which one needs to go where, like on the O2 circuit. Okay, any other questions? All right, the next one is our CTS circuit. Now I'm only going to draw this once. This applies to both the coolant temp sensor circuit and the air temp circuit. Okay, there's our coolant temp circuit, as is typical. Again, some have the ground feeding back to the ECU, but the majority of them, the one wire just goes to ground. So we're going to come out with our optimizer, and we are just going to take our CTS and splice it in. We are not cutting any wires for the coolant temp circuit. Optimizer 3X will have one wire per CTS circuit, and you have on here CTS1 and CTS2. That's two separate circuits because, you know, Dennis's Honda, like I said, it has a coolant temp circuit in the cylinder head. That's the one that the ECU uses to make decisions for cold start and so forth. That's the one that's going to help us achieve our goals. However, there's a second coolant temp sensor mounted in the radiator. And all it does is just verify that the cooling system is indeed working. Yet, if the two sensors have a wide disparity in readings, we trip a code. So if we're going to go and alter the signal of the one that really counts, we also have to go and alter the one in the radiator just to keep from tripping codes. So these two are independent. Well, it's two wires, but it's two different circuits on the 3X. Now, on the 4X optimizer, you're actually going to have two wires coming out.
What color is that one?
On the So on the 4X, you're going to have two wires per circuit. And you will literally take and run them across both sides of the sensor. Again, it's as if we just put a resistor between these two leads. The resistor is located inside the optimizer box. And the resistance varies from cold start through the warm-up cycle and whatnot. Plus, that resistance will be adjustable with the ammo box on the late 3Xs and all the 4Xs. Any questions on wiring this up from what I've covered so far?
How I can find out that the two wires coming up, or usually just the one sensor has only one wire and the ground himself, but like on the radiator sometimes plastic tanks, how I can find out if it's a ground there, or just check with the tester, that's it.
Okay, the question is, how can he find out if the sensor just goes directly to ground or if it goes back to the ECU? To be proficient at installing and absolutely necessary if you're going to do training, you have to have access to manuals that'll show you the wiring diagrams. This afternoon, when we get started on the installations, you will be provided an all data or a Mitchell version printout of the wiring that you need to know. Not tail light wiring and all that crap, but you know, what wires are going in and out of the ECU. And you know, location of the ECU. There's probably 2 or 3 wiring diagrams that you'll get. And they will tell you vehicle to vehicle what the answer to that question is. Now let's say that we're doing a 4X install and we have the sensor where the one side goes to ground. All right? Here's a shortcut. You can just take and ground the one wire and run the other wire at the ECU. So if you have coolant sensor, air temp sensor, you can actually take the second wire from both circuits, twist them together with your ground wire, and run all 3 to ground. And then run one of the wires here, one of the wires on your air temp sensor. So that would be a shortcut if you have a coolant sensor, air temp sensor, where the one side is just grounded. Does everybody understand that? Okay. If you do have a sensor where this goes back to the ECU, of course, you're going to have to tap into it directly.
What color are those?
Doesn't matter. Just read the box. You want to know what color it is? There you go. CTS1, CTS2. Now on the 4X, when you go in and you do the adjustments, if you are actually using both coolant sensor circuits, you're doing an install, say, on Dennis's Honda. When you adjust one, you adjust them both. They will always be approximately 200 ohms resistance different from each other. So if you adjust CTS1 and you're looking at your scan gauge, just know that CTS2 is just following up and down with your adjustments within 200 ohms of CTS1.
So it has more than one adjustment, it's not 2 separate adjustments? Yet?
Correct. Even though there's 2 CTS circuits, it's only one adjustment on the ammo box. However, the coolant sensor and the air temp sensor are 2 separate adjustments. Just to clarify that. All right, let me borrow this. Okay, oxygen sensor, never mind. Oxygen sensor, I know what I need next. Oxygen sensor. The way we're going to hook this up is we're going to go in, we're going to cut the oxygen sensor signal wire. And then, let's see here. Actually, see if I can use the right colors for this. And orange, ECU. And then we're going to hook up the appropriate wires. This is polarity sensitive. OS1 ECU is yellow and the sensor is pink. OS2 is orange to the ECU and brown to the sensor. There's 2 oxygen sensor circuits in both the 3X and the 4X. The reason is because you got minivans, pickups, V-configurated engines that'll have a left bank and a right bank, or front bank, rear bank. And so you'll have 2 circuits for both banks. If you have like a 4-cylinder that only has one, you only use one of those 2 circuits from the optimizer. Now, on the 4X optimizer, what we're going to probably do is you might have like an orange wire that's supposed to go to the ECU. And then you might have an orange wire with a black tracer that'll go to the sensor for OS1. Then it might be a yellow wire to the ECU and a yellow wire with a black tracer going to the sensor. So associated circuits, we're going to try to keep the colors the same so that at a glance you know that this wire goes with that wire. Same circuit. One thing you do not want to do is go from the optimizer OS1 and OS2 wires. You have to keep, 1 and 2 same circuit. Any questions on this? Yes, sir.
Does it matter which circuit you hook up if you only have one?
No, it does not. You can use OS2 and then tape OS1 back in the harness, or use OS1 and tape OS2 back in the harness. Same with coolant sensor. You can use CTS1 and tape 2 back, or use CTS2 and tape 1 back. Now, when you adjust your switch point, remember that graph, where the analog top and then the digital bottom? Page, I don't know, somewhere in the manual. When you adjust that 0.16 volt trip point, either manually or with the ammo box, manually you would do it through this little hole right here. When you adjust that trip point, you're adjusting both OS1 and OS2. So if you change up 0.16 volts to a quarter volt, you've changed it on both oxygen sensor circuits. However, the two circuits work independently of each other. So OS1 might be high while OS2 is low. And the optimizer will just send out the corresponding signal. So as OS1 is going like this and OS2 is going like this, the optimizer works both circuits independently, but the trip point will be the same on both banks. Do you follow that? Okay. So that's the basic hookup on the 3X. On the 4X, you've got a couple of more things. This color I haven't used that'll show up. All right, green. Map sensor circuit. What we're going to do when we alter the map sensor or a 12-volt VREF DC voltage out mass airflow sensor is we're going to cut the VREF. This we're going to tape back into the harness, the ECU side of the wire. Then we're going to come out of the optimizer and we're going to feed it our own 5-volt VREF. So if you have like a Ford frequency-based map sensor or a typical mass airflow sensor that is frequency-based, what you're going to do is you're going to cut that signal wire, not the VREF wire, the signal wire. And then you're going to have two wires coming out of the optimizer. You're going to splice in there. And then you're going to splice the other one in here. This is polarity sensitive. So again, you'll probably have like a green wire that goes to the ECU, and then a green wire with a black tracer going to the actual mass airflow sensor. So the mass airflow sensor has its VREF, has its ground, it has its signal that it's sending out to go to the ECU. We're going to intercept that signal. And then we're going to alter it and then send our altered signal back to the ECU.
That's on the 4X.
This is on the 4X. Any questions so far? We're going to have an additional circuit coming off of the optimizer that will just plug in. It is a thermal switch. The thermal switch will be mounted someplace on the engine where it is in intimate contact or near intimate contact with the cooling system. Freeze plug on the block, the head, somewhere like that. You could probably tie strap it to a heater hose, epoxy it to a freeze plug, but if you do the heater hose, make sure you insulate it well. Now here's how this is going to work. I already explained it yesterday, but we're going to review it again. Let's say it's a day like today. I believe it's less than 45 degrees Fahrenheit. So in your handout, Dutchman Enterprises Optimizer 4X description, if you flip over to the back, cold start delay. Now, if the temperature is about 40 degrees Fahrenheit, we're going to have a 1 minute delay, right? And we had established that that 1 minute delay means that when you activate the optimizer by starting the vehicle, for 1 minute, that optimizer in no way exists. It does absolutely nothing to any of the signals. Then after 1 minute, we go into our normal 5.5 minute countdown cycle.
That's only on the 4X.
That's only on the 4X.
What does the 3X do?
It just goes into the normal 5.5 minute countdown cycle immediately.
So somebody who's got a 3X box in a cold start condition.
What you're going to do on the cold start for the 3X for now is you're going to go in and cut that wire. The optimizer wire that goes to the coolant temp sensor circuit, just cut it or put a switch in there so you can somehow bypass it. There is a fix we're working on for existing 3Xs. Until we come up with that fix, the cold start solution is we will bypass the coolant sensor wire.
Okay. So put a switch in there so in the winter, if it's got a cold start issue, break it, open it, and then in the summertime when you get back to warm weather.
Or when we get the fix.
Or when you fix. Okay.
Yeah. So anyhow, we're going to have a 1 minute delay. Now, the scenario I used yesterday is, someone gets in their vehicle, it's 40 degrees out, we got a 1 minute delay, then we got a 5.5 minute timeout, and let's say they're at this class and they have a 4X installed and they're at the hotel 20 miles down the road. So they get in the vehicle, they come a couple of miles, everything is timed out. The engine's up to operating temperature. They pull in and grab a pack of cigarettes at the convenience store. They shut the vehicle off. They come back out and they start the vehicle again. And again, let's assume that the optimizer is located someplace where it does not get warm. It does not get warm because it's not getting engine heat, nor is it getting passenger compartment heat. So it's going to still be reading 40 degrees when the operator goes to start it up. It's going to want to go through that 1 minute delay, then a full 5.5 minute countdown. Well, because of this thermal switch, we can know, hey, the engine's already warmed up. Skip all of that. We're wasting a lot of fuel. We're ready to start taking advantage of all the benefits the optimizer can offer now. Not 5 minutes from now, not 10 minutes, not 15 minutes from now. Now. So this thermal switch will initiate what we're calling the 10X countdown. That 10X countdown was put into the optimizer. We don't even have one here to tear apart. Was put into the optimizer because every one of these get bench tested. And so the manufacturer bench testing these would take 5.5 minutes just to do the countdown on the circuit to make sure that it times out properly. The starting and ending resistances are where they're supposed to be, and there's no glitches. He has to watch every single step. With the 10X countdown, he jumpers 2 wires across in here. So there's 2 pins inside here that this thermal switch will be hooked to. So on the bench, he just plugs in a little jumper, and now it goes through about a 50-minute timeout. And instead of watching it on a digital voltmeter, he just watches it on the scope. He can see any glitches, and he can do, 5 of these in the same time it would take to do 1 through the normal countdown procedure. His costs go down. The cost to us is now gone down because the man hours involved to do this military spec testing has just been reduced. So we're going to take this test 10X circuit, put a thermal switch in here, and we're going to allow that timeout to go through in less than a minute instead of 5.5 minutes. So, a delivery van goes and stops, turns the engine off, goes up, delivers something, gets a signature, goes back in, drives less than a mile, stops, turns the engine off. This may make or break big contracts. You hear that, dealers? Because they waste no screws in it. Cool. Hey, baby. All right, are there any questions on this?
Okay, you said how much time it takes them, 15 seconds or 15 minutes? You said 15 minutes before. Was it 15?
15 minutes was mentioned. Let's assume that it's 0 degrees out. You're going to have a 10-minute delay before our 5.5-minute timeout circuit even starts. So you take the 10-minute delay plus the 5.5-minute timeout circuit, there's over 15 minutes it will take before the optimizer is fully online. And if it's less than 0 degrees out but the engine's up to operating temperature, we're going to do in less than a minute what would take 15.5 minutes to do without this circuit. Does that clarify it for you? Okay.
Somebody's car, Lex is still burning. Cobalt.
Pardon?
The gray cobalt. Lights are still on.
Oh. Thank goodness there's good heavy-duty automotive grade components in here.
License plate starts with EVA. Yeah, it's over there.
All right, there's a lot more stuff in here. I think I got everything that we're gonna actually need. All right. Nope, one more. There we go. That's everything.
What about your JP1 in ground? JP1 in ground?
I don't know. You know something I don't. First thing you'll note is right here on all of the 3Xs that have been manufactured so far, there is a potentiometer, an analog potentiometer, this little blue piece right here. This lines up with the hole on the end. This is where you adjust the oxygen sensor circuit with a pocket screwdriver. Right rich, left lean. You turn it clockwise, you're making the vehicle richer. You turn it counterclockwise, you're making the vehicle leaner. Right rich, left lean. So you come in with the pocket screwdriver and turn. That's how you adjust these early ones. And then later, this analog potentiometer will be replaced with a digital potentiometer that will allow you to adjust the oxygen sensor circuit with the ammo box. It is shipped from the factory, reading 0.16 volts on the trip point. 0.16 volts you can actually measure. On over half of them, there's a little test point Now you got 4, 1, 2, 3, 4. That would be 1, 2, 3, 4, these 4. Just to this side of this lower one right here, there's a little test pin P6. All it is just like a little bare spot on the board where you can go in with your voltmeter. So you take your black lead on your voltmeter to ground, you take your red lead to P6 with your black and red leads hooked up. That means you have battery voltage going to your optimizer. Then you go in with the voltmeter, ground to P6, and you can tell what your switch point is. It will be approximately 1.6 volts out of the box. That's how they're shipped. Now, if you have one of the early boards on a 3X optimizer, they did not have a P6. So this, right here, this little chip, top row of pins, far end pin will be the same as P6. Now I'm going to walk around and point this out. Right here is P6. And if you have an early board, this pin right here will be the same. So it's this pin, and there's P6. Here's our P6. And if you have an early board with no P6, be this IC chip, top row of pins, far end pin, which would be right here. Ground point would be right here. And then here is the potentiometer, the analog pot you adjust with the pocket screwdriver to change the O2 sensor reading. Next item of interest. We had an Optimizer 1X. A silly, very minor change was made, and we were dealing with a different electronics guy when the 1 and 2Xs were made. And with that one little minor change, he took it from a 1X to a 2X. So what's the difference between a 1X and a 2X? Virtually imperceptible. So then we come out with the 3X. Now 2X to 3X, yeah, that's a major change. We've actually had several revisions on the 3X in its run. This chip right here, is a microprocessor. If you have a 10-year-old IBM computer, this is what powers it. So in other words, it's not the latest and greatest, but if it'll do, an IBM computer, it'll certainly power our optimizer just fine. You'll see on that chip, it says Dutch OP3X RC-C19D. What does that mean? Absolutely nothing to you or me, and it doesn't need to. But what that means is that's the version of the 3X optimizer that's been burned onto this chip. This chip is read-only and burn-only. So the program is put on the chip. That which makes everything work in here all revolves around this chip. So if somebody wanted to copy this, they could copy the hardware, and it won't work until you program the chip. The chip program, you cannot offload from the chip. You can burn over the program. This chip can be burned over several times, quite a few times, but you're not going to get the software off of it. So that's what that number means. Now on the end of the unit, there's a serial number. That serial number is replicated on the back side of this relay. So it's both internal and external. So we have two serial numbers, exact same number but posted twice on here. This relay itself is what powers our Keep Alive memory. When I said about the board mount relay, when you turn the key on, that'll click. Now, right here is a green dot. This green dot signifies that this unit has gone through the military spec testing, that this serial number will have a data sheet of all of the values, all of the adjustments and everything, that everything functioned properly. If it's got an analog pot, it was taken full sweep to make sure there was no steps or bad spots. And I think out of 1,000 units, there were 3 bad pots that never made it out of the factory because of that military spec testing. Next thing, there is a white connector with 2 red loop leads right here. This connector encompasses 4 pins on the board. So if you're going to look at this thing up close, you're going to find that there is a 5th pin right next to it. We call this our Ford jumper because Ford, Mazda, Jaguar, and possibly 1 or 2 other makes, the resistance values on the sensors are much, much higher than they are on the Toyota and the Chryslers and the GMs. And what happens is, with the resistance values that work fine on most of the cars on the road, you turn the key on stone cold and you're already tripping a high temp code. The temperatures are like off the scale on the Ford, Mazdas, the Ford-based systems, because the resistance value is so much higher. And so what you do to turn the 3X optimizer from most everything to a Ford is you unplug this connector. You shift it over 1 pin and then plug it back in. So there's 5 pins. And then when you're done, to be a Ford version, you'll have that 5th pin located over on that side of the connector. I'm going to walk around. I'm going to probably show you 1 or 2 other things yet, and then I'm going to walk it around.
Is that something that's on the directions that come with the kit? To switch?
I don't know what instructions they have in the kit.
It doesn't have it.
It doesn't?
It comes with a tag on it that says it is Ford compatible on the optimizer. Actually, the tag is on the cellophane that's around it.
Okay, I'm going to cover one other thing here, just because there's word of it out there. There's a little jumper lead right here. And if you cut this jumper lead, that will affect either the coolant or the air temp. I think it affects the coolant sensor. So cutting this lead turns it into a Ford version coolant sensor, but not air temp. Moving the probe, the plug, will make both of them Ford style. If you both move the plug and cut the lead, it's the same as one or the other. If you move that plug, it's the same as cutting the lead. So word has been put out that you're supposed to cut this lead also. Does not make any difference. If you move the plug, it's the same as cutting that lead. Now, let me get caught up and show you guys before I go. Now, I'm going to do the last one. All right, there's a row of prongs along the bottom here. This is where on the 3X you will interface the optimizer. So there's going to be a special adapter for the 3Xs that will interface the optimizer to the 3X, because the the ammo box to the 3X. Everybody recognize the plug on the bottom of this?
Phone jack.
Nope. It's an 8-wire. It's close to a phone jack. Very, very similar to a phone jack, except it's an 8-wire. Very universal. Best Buy, Target, Walmart, probably McDonald's has them. They're everywhere. So if you have the optimizer mounted underneath the hood of the vehicle and you run this cable up along through, you slam the hood and it severs the cable, you don't have to call us and say, look, I need another one of those expensive specialty cables. You can go down and you can purchase the standard plug and you're back in business again. However, for the 3Xs, there will be an additional box that'll have a special plug that'll plug into here. So this row of pins is your ammo connection. Over here, there's 2 more pins. That's your 10X connection. Hypothetically, you could put a thermal switch. You know, those little extra tricks that I'm going to teach you later on today? One of them is you go to this port and you can like have a manual bypass switch on a 3X, or you could do a thermal switch, and then when the engine's warmed up, it'll go through a 50-second timeout instead of a 5.5 minute. Okay, guys, somebody pointed out to me that it's not these two pins. So you guys in the back, I showed you the wrong two pins. It's not those two, it's actually these two. So you have your row for your ammo box, a little space, and then there's two more, because it says right on there. I didn't even read the board. So I'm going to come over here and do this for art. Let me grab something to point with. All right. These two pins right here are your accelerated timeout, 10x circuit. By jumping these two across, you will actually create a 50-second timeout instead of a 5.5-minute timeout. This row of pins here is where you will connect the ammo box to on the 3X models. This little wire right here, that is the one that's been floated around. If you cut that, you're going to change either the coolant or the air temp circuit over to Ford resistance values, but not both. And then by looking here, the extra pin is over here. So this is currently in the Ford test mode. By unplugging this connector, shifting it one pin this way, and plugging it back in so that my 5th pin is now on this side, this is normal mode. And then this blue thing here is our potentiometer that we go in with the pocket screwdriver to adjust the O2 circuit on. So this pot won't be on versions set up for ammo box. So if it is set up for an ammo box, this won't be here. It'll be another chip looking somewhat like this. All right, this is connected to another board. This is essentially what your connectors look like. And they will be shipped with the connector plugged in to this row of wires. Just like that. So unless you do anything, it'll already be like this. You take the cover off, and that's how it'll be plugged in.
Is there an extra pin on that?
Yes, there is. And I believe the extra pin goes to the top side, but don't quote me on that. I don't work with these often enough. But at any rate, let's say that you have a bad optimizer box, or you suspect a bad optimizer box, and it took, an hour to wire this stupid thing up. So you get the new ammo or optimizer, you can just simply unplug the connector, put the new optimizer in, and plug it back in again, instead of re-splicing all of those wires. And the 4X will have a similar feature, where you can just unplug the whole wiring harness internally. Okay?
That's the 3X.
This is a 3X. There are no 4Xs in existence at this time.
But the plug is going to be similar or same?
There'll be a plug. I have no idea what the plug will look like, but there will be a plug. Okay. Any questions on anything that we've covered this morning? You feel confident you could actually wire one of these babies up on a vehicle, right?
You should have them make the connector the same, so we can upgrade the 4X to a 3X without wiring.
Pardon?
They should have the connector the same, so we can upgrade to a 4X without having to rewire it. Just unplug the harness.
It's not going to happen. The wiring's too incredibly different. Too incredibly different. All right, let's go into tuning. So what do you turn? How do you know when you've turned it far enough or you've turned it too far? What are you trying to accomplish when your goal is fuel economy out of an HAFC-equipped vehicle? This is the make it or break it part. 98% of the people who have gone through the class have no problems whatsoever hooking up the hardware as per the board in the back. 98% of the people have no problems physically mounting an optimizer in the vehicle. 90% of them can even get the wiring right. What happens if you don't hook up the red wire? I'm not getting any mileage gain. Had one guy do 3 installs and didn't hook up the red wire because he thought, well, you don't need all these wires, do you?
Takes all kinds.
Little silver Honda out here, I need to move it for a minute, got land cruiser blocked in.
Silver Honda. All right, taken care of. So hooking up the HAFC kit is not ungodly difficult. However, out of 80-some students who have thus far gone through the class, we've had 12 who have successfully done an install, successfully tuned that vehicle where they got a minimum 50% increase. There was one guy who did 3 installs, all 3 of them, the worst case scenario was a 73% increase. There was just a class done in North Dakota, 3 vehicles with no additional fuel economy tricks. All 3 vehicles wound up in the 50-some% range. So it can be done. There's people out there convinced this does not work. There's nothing you can do. I've done 3 vehicles. I can't get one of them to give me even a 20% increase. I hate to break his heart, but he is not competent. I either didn't do my job properly and train him to successfully do this, or he is not knowledgeable enough about the automobile to be able to tune it. I can fix one of the 2, hopefully. If you are not knowledgeable about the automobile, that's up to you to fix. I can't fix that for you. But I am going to try to cover the tuning more in depth. So the first thing that gets tuned is the fuel cell. That is a foundation. If you change anything else, if you adjust any other parameters and your fuel cell is not performing properly, then you're going to have to go back and retune again later. By tuning the fuel cell, we're going to adjust the electrolyte so that when the fuel cell is up to operating temperature, the engine is up to operating temperature, we want approximately 15 amps per cell. On these older units, that means 15 amps. On the newer setup, if you're going to actually use both sides on a V8 or something, then you're going to have 15 amps on both sides. But you can only tune the electrolyte once because the same electrolyte is going to feed both sides of the cell. Yes, sir?
So with both of them on this newer one, it will not be able to vary, like we want 22 amps or something to make it like 75 liters of gas?
When you start cranking the amps up, you're cranking the temperature up. The number of cells, the amount of surface area, these systems work best while drawing 15 amps. If you crank it up to 20 amps or 22 amps, what you're doing is you're shorting out the plates. You're getting an increase in flow of electricity, which would show up as a higher amperage rating. But that does not mean that your water gas output goes up. You may get 60 liters per hour at 15 amps, increase the concentration of electrolyte to 20 amps, and your little test will show 68 liters per hour. But I assure you that a good portion of that additional 8 liters per hour is steam, because the additional amperage generates additional heat. That additional heat will literally boil the water out of the electrolyte.
I meant as a combination between the 2 of them set up.
They're on separate wires, separate circuits. So your left bank has its own positive wire, its own fuse, and its own relay. Your right side has its own fuse, its own relay. So you will actually set both sides up. You can test it one at a time. They should be the same. So if you're doing the older one, you only have one positive wire. It should read 15 amps. At operating temperature. And I'm going to add that also. So once you get the fuel cell set up, next thing you're going to do is you're going to tune the coolant circuit. On your scan gauge, you're going to be looking for about 215 to 220 Fahrenheit. If you have a vehicle that does not have an electric fan, 220 is preferred. Vehicles with electric fans may trigger the electric fan at, say, 216. So you want the temperature to be right under the fan trigger.
Mike, turn the board just a little bit. Yes.
Mike, what if you've got a vehicle that does have an electric fan, that before we touch it, The scan gauge reads that it's kicking off at 222, or the fan's kicking on at 222 degrees, and it's kicking off at 210 degrees.
Your low side doesn't matter. Your high side, your 222 or whatever it is, you get it up around 217, 218, great, because unless you exceed that 222, the fan won't kick on. Its kickoff point is simply because there's a bimetal spring. It's probably like a fan switch, or it's a comparator circuit that has a wide loop back. There's a little resistor that goes from the output back to the input, and the value of that resistor will determine how wide that swing is.
So at that point, in that instance, I wouldn't have to adjust it at all, or put any resistance.
You're
on it
still
at all.
going to be targeting, 215 to 220. If you're kicking the fan at 222, you can go to 220, and that's fine. Because if your fan kicks on at 222, you never exceed 221, even if the kickoff point is 175. As long as you never hit that 222, the fan doesn't kick on. You want your coolant circuit adjusted right under where the fan's going to kick on if applicable. Otherwise, 215 to 220. Once you get up around 230, 235, internal cooling mode. That's the OEM's way of protecting their warranty engines. If you blow a radiator hose or something and the thing starts getting hotter and hotter and hotter, then the computer will just start dumping copious amounts of fuel into the engine, hoping that the latent evaporation process will keep it cool enough that you don't kill the thing and they have to buy it. That is worst case scenario. The hotter the better, not necessarily. So what adjusting this coolant circuit is going to do is allow us to adjust our oxygen sensor circuit without the computer fighting us. If we just go in and try to lean out the fuel by adjusting the oxygen sensor, the computer's going to say, no way. I don't buy that for a minute. So we go in and we change this parameter. Now that allows us to go even leaner on our oxygen sensor circuit parameter. So if you're trying to lean it out, you've got plenty of power and you're tripping a low O2 voltage code, recheck your coolant sensor circuit.
How's it adjusted? Let's say you have the...
I'll get to that. I'll get to that. Any questions on what numbers we're looking for here?
Pretty much so, wherever the vehicle comes in the garage originally before the install, it's wherever the fan is kicking off at.
If you have a 195 thermostat, your scan gauge before you install the optimizer should say 195. And the thermostat is going to keep those temperatures consistent. So whether it's this time of year, February 15th or July 15th, that coolant temperature is going to be very consistent. So we can adjust this any time of year, and we're still going to look for these type numbers. We don't want the cooling fan kicking on because that puts an additional load on the alternator. It takes horsepower to do that, which means additional fuel. So we just set this just underneath the fan kick point. Oh, is that from our electronics guy in the southern Los Angeles area?
This is a
Crossword puzzles.
Has a letter in it that says sorry. No, nothing there. All right, just those things.
Unfortunately, where's the other two? Call them back, say we need 2 more of these. What's the deal here? What's the deal?
I don't know, but I think one beats the heck out of none.
Yeah, yeah.
One at a time.
Arg. Well, my overlay ain't going to work without some redesigning. Excuse me, my wife's overlay. Yahoo! All right. This is a functional working ammo box. Let me rephrase that. This has just been shipped where it is assumed that this is, okay, this is a 3X optimizer that has had a few modifications done to it so that it will work. Look at this, man. There's no analog pot here. That little blue pot, you cannot adjust this with the pocket screwdriver. Has to be done with the ammo box. Hey, there better be instructions because I don't know what the different codes are. Seriously, remember we showed the different blocks, you know, 1, 2, 3? Well, they mean stuff.
No kidding. Oh, yeah. That's what you told us.
And let me see here. Okay, yeah. Just as a point of reference, you can see that the connector is connected where I said it would be, but it's at the far this end of that entire row of pins. Also, our blue potentiometer for adjusting our oxygen